Hi guys, so I'm going to be going over a grade 12 maths paper 1 November 2019 paper. So the first question is a solve for x1. Okay, so we're doing question 1 here. First question we have is solving for x. So 1.1 should always try and pay attention to the mark allocation. So we have x squared plus 5x plus 5x minus 6 is equal to 0. Right. And then so what we want to do here, we want to factorize these. First thing you do is you look at if there are any common factors, which there aren't in this case. So if you factorize x squared, you can have x times by x, that's x squared. For 6, you have to think a bit harder here. So you can either have 3 times 2 gives you 6, 2 times 2 gives you 6, or 6 times 1 gives you 6, right? But here you have a negative sign, that's because you have a negative sign that tells you that the roots that you calculate, the signs are going to be different, because if you have a positive and a negative, then you can get a negative, because if the signs are the same, you'll have a positive there. So you want something that you can have a difference of and then be able to have a 5. So that has to choose these two, 6 and 1. But then you can say you have a positive 5x, so which means that 6 is going to be on this side. 6 is going to be, because you want to have 6 positive 6x minus x gives you positive 5, right? So you can quickly check this by just distributing out, taking x squared, that's the term you're looking for, 6x minus what? 6x minus that x gives you 5x, and similarly 6 times negative 1 gives you negative 6x. So you know that that's correct. After you've done that, you must give what the value for x is actually. So it's x is equal to negative 6 or x is equal to 1. Right. So what you can do here, you can also quickly check if you say 1 squared plus 5 times 1 minus 6. 1 plus 5 is 6 minus 6, that gives you what? 0. So you know how this works out. Quickly check this one. Negative 6 power of square, that's 36, minus 5 times 6, that gives you 30. So that's 36 minus 30, that gives you 6. 6 minus 6 is 0. So you know that this also works out. Then you can move over to the next question. Okay, so we move over to 1.12. So here we have a quadratic equation for x squared plus 3x minus 5 is equal to 0. So you see, since they said corrected two decimal places, that gives you a hint that you're going to have to use the quadratic formula. And the quadratic formula, because here for 1, if you look at it, the anti-factor we can take out, and the quadratic formula can be written by negative b plus square root of b squared minus 4ac. 4ac. So just try and commit this to memory. It's going to save you a lot of time. And we know that from the quadratic equation that this is a, and this is our b, and this is our c. So the constant. We just substitute those values. Negative b is negative 3 plus minus square root of b squared. That's 9 minus 4a. A is 4. C is what? It's negative 5. So you have to show your workings to get full credit, because you can just insert this on the calculator. So you also have to show that you've done some workings and maybe simplify one more step. And then you have negative 3 plus minus square root of 9 minus minus, so that's positive 16 times 5, right? And then you can just substitute this on your calculator. So I've already done it here. So these are the two. Those are the two values for x. So x is equal to what? Positive is 0.837 to two decimal places, 0.0, right? Or x is equal to negative 1.55. Okay, that's that. Our next question is 1.1.3. So here we have 4x squared minus 1 is less than 0. So what you have to notice here is that this is an inequality. So you're looking for a range of of x values that are going to satisfy this equation. So you can try and factorize this. You should have done some exercise on this so that you know that if you have something like this, which is both of these, you can square. If you square this, you have 2x, 2x, you have 1 different signs. So, and then once you have this, you can have what you call critical values. So those are values where this sign is going to change, like values of interest. So if you do a number line, right, so you have a negative half, positive half. Now what you want to figure out is how does the sign of this change as the x values move between these two lines, between these intervals. So for instance, if you take this one, right, so just choose a number above the half. So if you choose, say you choose 2, so you see that this is going to be positive, -1, so this sign is going to be, overall is going to be positive. And then similarly, say you choose 0. If you choose 0, that's going to be 4 0 squared -1. The answer is overall is going to be negative. And if you choose something less than negative a half, so what's good that would be is you're gonna have a negative and a negative. Sorry, you're not gonna have a negative because this is x squared, so this is gonna be a positive. But then if you have, for instance, if you substitute negative a half here, negative a half is gonna be 1 to the power of 4, so it's gonna be 4 over 4, which is 1 minus 1, which is gonna be 0. So you can use this as well. So you can substitute here, try to figure out what that is. So if you substitute like a very big negative number here, say negative 10 plus 1, that's going to be overall negative. A big negative number here, same thing, negative minus 1 is negative. Then that's going to overall give you a sign of a positive sign. So because you're looking for values of x such that this inequality is less than 0, you can see also you have to pay attention that the inequality is not equal to 0. It's just less than. So that will mean the answer you're looking for here is going to be for values of x that are less than a half or they're more than a negative half. Then that's your solution. And so we're going to be doing 1.14. So this is like a nice interesting question of square roots. So one thing about square root, sometimes you want to write it as a power, something that way you can make it easier for yourself to process what they're looking for from you. So the first thing that I'll do actually here is that I'm just gonna make this half. So you see this is the same thing, because what I'm just saying here is that if you had the square root of 32 minus x, so if you had distribute this back in, you're gonna end up being in this situation, right? So it's equal to x. Another thing that you have to remember from is that if you have, say you have square root of a plus 1, square root of a minus 1, the answer to this is a minus 1. So you can test it out for yourself. So if you apply the same thinking to this, you're going to have that the overall answer is going to be 32 minus x. Minus x squared in this case, because we have an x times a negative x, which is x squared. So it's 3 to the power of a half, which is equal to x. So now what to simplify further, sorry for that, to simplify, okay, just remove this one. To simplify further here, simplify further, we're going to have 32 minus x squared equal to x squared. So let's just take the power to the other side, multiply by the same. Okay, and then here, so if you simplify this, you can have x squared plus x squared minus 32 is equal to 0. So just move this to the other side. So you have 2x squared minus 32 is equal to 0. So if you just divide by divide by 2 across, you're going to have negative 0, which, using the same logic that I outlined earlier on, you can simplify this to be x minus 4, x plus 4 is equal to 0. So this is x plus 4. So therefore x is equal to 4, or x is equal to negative 4. You can try out that answer to see if it works out. Okay, so now we're going to move over to 1.2. So this is a simultaneous equation you're solving for x and y. So what you have to do is just think about these two equations as equation 1 and the other one, think of it as equation 2. So what you want to do here, you're going to substitute one equation on the other. So you always just choose the simplest one to write, the one that you're going to substitute using. So if you make y is equal to 12 minus x, so that means we have y as written as a function of x, and then you can substitute this to the second equation, which gives you x is equal to 12 minus x is equal to 14 minus 3x. And then you distribute in, you end up having 12x minus x squared is equal to 14 minus 3x. So and then if you move, just to simplify, so you end up, you can have, take this one to the side, you have 15x minus x squared minus 14 is equal to 0. And so now you have to simplify further, just divide by negative across, and we have x squared minus 15x plus 14 is equal to 0. Now you want to factorize, right? Because then the common factor you can take out. So you have to let's think about factors of x squared. That's just x and x, straightforward. So now if you think about factors of 14, so with factors of 14 you can have 14 times 1, you can have 7, you can have 7 times 2. Okay, and then now you have to decide which of these two to use, right? But then you want to get back to 15, right? By when you're adding or subtracting, then you're going to have 15. So which means that most likely we're going to be using this one. So let's just think through it. So 14, the signs are going to be, you want something that's going to have, signs are going to be the same. So you can have overall, you can have a positive constant. So now the signs are going to be the same, either going to be negative or positive. But then because we have a negative somewhere, it means we have to have a negative. So they are both going to be negative, and then you can just put in any order, the 14 and the 1, because that's the combination that's going to give you a 15. And you can quickly test this for yourself. So this is x squared, and this is negative x. This is negative 14x. Negative 14x, negative 14x, negative x, that gives you negative 15x. X squared, you already have that. Multiply these two out, negative 1 times negative 14, that's a positive 14. So you know, at least you've got that one too. So therefore here, but then remember what they asked us, we are looking for x, and it's going to solve this equation simultaneously. So x is equal to 1, or x is equal to 14. X is equal to 14. Okay, so now remember our equation that we determined was 12 minus x. Let's just double check if that's the case. Yes, it is. So then substitute what you have for y. To get y, you have 1 now, so you have 12 minus x, that's 11. Now similarly here we have y is equal to 12 minus 14, right? So it's 12, y is equal to 12 minus x. So let me say 12 minus 14, which is negative 2. And finally, your last value is 14 and negative 2. This is x, this is y. So you can just make it easier for the person who's marking you, so you can make sure that they can credit you the appropriate marks. So it has sometimes even indicate that you understand this. This is x1, this is y1, this is x2, this is y2. So this combination, or this combination. Okay, that's the lesson. Okay, hi guys. So we're gonna be doing the last question of question one. That's 1.3. This one is a bit tricky, requires you to think a bit. So 1 times 2 times 3 times 4. So sometimes with these questions, it tends to be like a smart way you can quickly solve this. But then sometimes you have to try and balance, trying to come up with a smart solution versus the time that you have. Because sometimes you can just kind of manually just go through it, and if you are within the allocated time, then that's fine. So okay, determine the largest value of k such that 3 to the power of k is the factor of this product. So what does having a factor mean? So if you have this, say you have 6, then you ask someone asking that is 3 a factor of 6? That yes, it is, because you can write 6 as 3 times 2, right? So in a way, the way I'm thinking of this is like, just think about where you can have 3 in this entire sequence, right? So you have 3 here, you can have 3 again at 6, you can have 3 again at 9, and so on. So that's how I'll just approach it. There probably is a smarter solution to this. So maybe if you did it in a different way, feel free to tell us how you did in the comments. Okay, so the first 3 you're gonna have, right? That's the first is this one. So you're gonna have 3, and then another place gonna be at 6, which is 3 times 2. The next place is gonna be at 9, right? Because that's gonna be 3 times 3. And then the next one is gonna be at 12, because that's 3 times 4. Then the next one is 15, because that's 3 times 5, which is 15. The next one is at 3 times 6, which is 18. But you can also think of this as 9 times 2, right? So maybe you want to write this as 3 times 2. Okay, yeah. And then the next place you're going to have, so that was just it. Next place is going to be 3 times 7, which is 21. The next one is going to be 3 times 8, which is 24, right? So you see, getting quite close, and then we haven't really spent much time. 3 times 9, which is 27, or you can also think of this as 3 times 3 squared, which is 3 to the power of 3, right? Then the next one is going to be 3 times 10, which is the last term of the sequence, actually, which is that 30. So basically, the max number of k that you can have that be a factor is when you count all these 3's, you add all of their exponents. So you see, so this is 1, this is going to be the 1, 2, 3, 4. Oh yeah, okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So k is equal to 14. Right. Okay, let's just double check that. So let me just explain what I'm doing here. Right. So I just kind of figure out where, like if you take all the terms that are here, so you want to take out all the 3's that you have, so you can make sure that it can't be a factor anymore. Say 3 to the power of something, right? First one you're going to take out is this 3, right? So that's the first one. Second one is at 6, 3 times 2. So that's the second one. The next one is at 9. So now you have this 3 to the power of squared, right? So that's when you end up having 4, because we have to add this 2. We're sitting at 5 here, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So that's why you have 14. So as I said before, it might be a quicker way, but I think that actually does it in time. So sometimes you just have to, because what they're looking for is that you can actually apply your mind a bit and just think about what does it mean to actually be a common factor of a product.